Trigonometry exam prep. Now, as a recap, the following topics were covered within this section. We covered the trig functions, also known as the trig ratios, which are applicable to right-angled triangles such as the one shown. We covered sin x equals opposite over hypotenuse, cos x equals adjacent over hypotenuse, and tan x equals opposite over adjacent. We had the handy mnemonic SOHCAHTOA, which is a handy way to remember these three trig ratios. We then moved on to the graphs of these trig functions. We covered the sine graph or the sine wave. We covered the cosine graph, and we also covered the tangent graph. We introduced the quadrant rules, which can be used to work out the recurring values of periodic functions, such as the sine, cosine, and tangent functions. And then we moved on to transforming graphs of trig functions. We covered four transformations. We covered vertical translations, where we were shifting a graph up or down by c units. We covered horizontal translations, where we were shifting a graph left or right by p degrees. Vertical stretches, where we were multiplying all the y coordinates of f of x by a. And horizontal stretches, where we were dividing all of the x coordinates of f of x by b. We then discussed the solving of trig equations, and then we moved on to trig identities, the two trig identities tan x equals sin x over cos x, and sin squared x plus cos squared x equals 1, and we discussed how we can use the trig identities to simplify trig expressions. We then covered how we can use trigonometry to find the area of a triangle. The area equals half the base times the height of a triangle in general terms, but in trig the area equals half AB sine C. We then moved on to the sine rule, a rule that can help find the length of an unknown side or the size of an unknown angle in non-right angled triangles. As shown here, we can use the sine rule when we have two sides and one opposite angle, or one side and any two angles. We then moved on to the cosine rule. Again, we use the cosine rule to find the length of unknown sides or the size of unknown angles in non-right angled triangles. We can use this form of the cosine rule, the a squared equals b squared plus c squared minus 2bc cos a form, when we have two sides and an angle between them. And we can use the rearranged form, cos a equals b squared plus c squared minus a squared over 2bc, when we have all three sides and we wish to find an angle. We then moved on to introduce bearings, or working out the direction of travel. And then we finished off on problem solving, which we introduced a process which can be used to determine which set of rules or formula we should be using to help solve questions on triangles, whether they are right angle triangles or non-right angle triangles. This topic will now cover the types of trig question you are likely to see in your exam. You will have multiple trig questions in your exam. Over the last few years, approximately 15% of exam marks involved trig questions. That's 15% of all the marks in the exam involved trig questions. Hence, it's very important you study this section thoroughly and practice until you have mastered all the skills within it. Our first couple of questions are on trig graphs. In 2015 paper 1, question 6 for 2 marks, part of the graph of y equals a sine bx is shown in the diagram. State the values of a and b. Okay, before we answer this question, let's have a quick recap. We introduced the general form of transformed graphs as y equals a sine bx plus c. This could equally be a cos bx plus c or a tan bx plus c. In this general form, a is the amplitude, which is half the distance between the max and min values, and this represents a vertical stretch. B is equal to the number of waves between 0 degrees and 360 degrees. This represents a horizontal stretch, and the new period of the graph would be 360 over b. And C represents a vertical translation, how much the graph has been moved up or down. Now, with those notes in mind, let's go back to our 2015 question. Y equals a sine bx, state the values of a and b. So first let's look at a. We know that's our amplitude, and that's half the distance between the max and the min values. Now looking at this graph, we can see the maximum is 4 and the minimum is minus 4. So half the distance between 4 and minus 4, well that's 4 minus 4 over 2, which is a over 2, which is equal to 4. So a equals 4, and our vertical stretch for this graph is 4. Although it hasn't been asked for, just as a note, c is equal to 0. There is no vertical shift for this graph. So let's move on to work out b, the number of waves between 0 degrees and 360 degrees. So let's count the waves. Here we have 1 wave, 2 waves, and 3 waves. So we have 3 sine waves from 0 degrees to 360 degrees. So b is equal to 3. So our answer to this question is a equals 4 and b equals 3. Okay, the next question, 2019 paper 1 question 13, again for 2 marks. Part of the graph of y equals 3 cos x plus 45 degrees is shown in the diagram. The graph has a minimum turning point at A. State the coordinates of A. Now you should know that the graph of y equals cos x, which is the root of this transformed graph, has a minimum turning point at 180 degrees and minus 1. So x coordinate 180 degrees, y coordinate minus 1. So the way we work out the transformed minimum turning point, or the minimum turning point of the transformed graph, is we step through each of the transformations applied to this graph one at a time and see how the minimum turning point moves as we step through those transformations. So let's take the first transformation, y equals 3 cos x. So this is a vertical stretch, so we'll be multiplying all our y coordinates by 3. This means the minimum turning point becomes 180, x coordinate unaffected, but our y coordinate is multiplied by 3, so minus 1 times 3 gives us minus 3. The next transformation is the horizontal translation, where we add 45 degrees, also known as our phase angle. Now adding 45 degrees shifts the graph left by 45 degrees. So our minimum turning point, which was 180 minus 3, now becomes 180 minus 45, and y coordinate stays at minus 3. So A, our minimum turning point, becomes 135 degrees minus 3. Our next question is on trig equations. In 2016 paper 2 question 14, for 3 marks, we're asked to solve the equation 2 tan x plus 5 equals negative 4, where x is in the range 0 degrees to 360 degrees. Now on the right we'll see the method that was introduced in the topic on solving trig equations. We want to find the solution in the first quadrant, then we use this solution from the first quadrant to find the solutions in the required quadrants by applying the quadrant rules. So find the solution in the first quadrant, then find the solutions in the other quadrants required. Our quadrant rules are shown here on the bottom right hand side. So let's jump in and solve this equation. 2 tan x plus 5 equals minus 4. Using our method line, we want to get x on its own, so let's subtract 5 from both sides. This gives us 2 tan x equals negative 9. Now we want to divide by 2. This gives us tan x equals negative 9 over 2. And we've earned ourselves 1 mark. Now recall, for first quadrant calculations, we want to work out the value without the negative sign. So we'll be working out tan x equals 9 over 2 for the first quadrant. Okay, how do we get x on its own? Well, we take the inverse tan of both sides, so let's do that. So x equals tan to the minus 1, 9 over 2. Positive 9 over 2, first quadrant, we work out the value without the negative sign. Plugging these values into our calculator, shift tan 9 over 2, x is equal to 77.5 degrees to 1 decimal place, and we have our first quadrant value. Now we need to ask ourselves, which quadrants do we need to find the x value for? Well, tan x is equal to negative 9 over 2. So we need to understand in which quadrants is tan negative. Looking at our quadrant rules, we can see that everything is positive in the first quadrant, and tan is positive in the third quadrant. So tan is negative in the second and fourth quadrants. So we need our equivalent angle in the second and fourth quadrants. And the rules for this are, second quadrant is 180 degrees minus theta, and in the fourth quadrant our equivalent angle is 360 degrees minus theta. So x becomes 180 degrees minus 77.5 or 360 degrees minus 77.5. So x equals 102.5 degrees or 282.5 degrees to 1 decimal place, and this will earn us the additional 2 marks that we need to take us up to the 3 marks. Our next 2 questions are on trig identities. In 2019 paper 2 question 17, for 2 marks we're asked to expand and simplify brackets sin x plus cos x all squared, and we're asked to show our working. Okay, so let's do that. Sin x plus cos x all squared, we use algebra to expand the brackets. So this is the same as sin x plus cos x times sin x plus cos x. Let's multiply out the brackets. This gives us sin squared x plus sin x cos x plus sin x cos x plus cos squared x. Collecting like terms, we have sin squared x plus 2 sin x cos x plus cos squared x. Now this is where we have to introduce our trig identities. We have 2 trig identities, tan x equals sin x over cos x, and sin squared x plus cos squared x equals 1. You must memorize these trig identities and understand when to use them. Now going back to our answer so far, sin squared x plus 2 sin x cos x plus cos squared x, we know that sin squared x plus cos squared x equals 1. So let's rearrange our answer so far, and we get sin squared x plus cos squared x plus 2 sin x cos x. Now we can substitute in the 1, and this gives us 1 plus 2 sin x cos x, which is our answer. In 2016 paper 1 question 11, also for 2 marks, we're asked to simplify tan squared x cos squared x, and we're asked to show our working. So let's do that. Tan squared x cos squared x, now we know that tan x equals sin x over cos x, so let's substitute that in. This gives us sin x over cos x all squared times cos squared x. Taking the square into the brackets, we have sin squared x over cos squared x times cos squared x. Now we can simplify this by cancelling like terms, and this gives us sin squared x, which is our simplified answer. Our next 2 questions are on non-right angled triangles. So in 2019 paper 2 question 3, for 2 marks, the diagram shows triangle PQR. PR is 45 centimeters, PQ is 70 centimeters, and angle QPR is 129 degrees, an obtuse angle. Calculate the area of triangle PQR. Okay, first thing we want to do is label the sides. Side P is opposite point P, side Q is opposite point Q, and side R is opposite point R. Now we want to calculate the area of this triangle. The trig formula to calculate the area of a triangle is a half AB sine C, and we need 2 sides and the angle between them. Now looking at our diagram, we see that we do have 2 sides and the angle between them, so we can use area equals half AB sine C. Let's put this formula into a form for our triangle, and this gives us a half times QR, the 2 sides, and then the angle between them, sine P. Plugging in our values, we have a half times 45 times 70 times sine of 129 degrees. Plugging this into our calculator, we get 1224.004 centimeters squared to 3 decimal places. Okay, in 2018 paper 1 question 10 for 2 marks, in triangle XYZ, XZ is 10 centimeters, YZ is 8 centimeters, and the cos of Z is equal to 1/8. Calculate the length of XY. Now trig questions such as these normally appear in paper 2, the calculator paper, as we need to use our calculator. But this question appears in paper 1, hence why we've been given cos of Z is equal to 1/8. So we don't have to use a calculator. They've told us what the cos of angle Z is equal to. Okay, as before, let's first label the sides. Side X is opposite point X, side Y is opposite point Y, and side Z is opposite point Z. Okay, let's mark on our angle. So cos of Z, angle Z, is equal to 1/8. This is not a right angle triangle, so we can either use the sine rule or the cosine rule to calculate the length of xy or calculate the length of z. Now we have two sides and the angle between them. When we have two sides and the angle between them and we want to calculate a side, we can use the cosine rule. A squared equals b squared plus c squared minus 2bc cos a. So let's use that. But let's put it into a form we can work with. We're looking for side z. So z squared is equal to x squared plus y squared minus 2xy cos of angle z. Plugging in the values we have, 8 squared plus 10 squared minus 2 times 8 times 10 times cos of z, which we are given as 1/8. Now we can do these all without a calculator. 8 squared is 64, 10 squared is 100, and what we get is 164 minus 20. So a squared is equal to 144, and the square root of 144 is 12 centimeters. So a is equal to 12 centimeters. Now just a point of note here, and when you do a square root you normally get a positive value and a negative value. So a could be plus 12 or minus 12, but as a length cannot be negative, a is equal to plus 12 centimeters. Our next question is a triangle problem solving question. 2016 paper 2 question 8 for 3 marks. A set of step ladders has legs 150 centimeters and 140 centimeters long. When the ladder is fully open, the angle between the longer leg and the ground is 66 degrees, and we're given a diagram showing these dimensions marked on it. Calculate x degrees, the size of the angle between the shorter leg and the ground. Okay, so let's go through our problem solving decision making process. The first question we want to ask ourselves is the triangle shown right angled? And no, it's not a right angled triangle. Now given it's not a right angled triangle, we will likely be using the sine rule or the cosine rule to answer this question. Now both the sine rule and the cosine rule are provided, the formulas for these rules are provided in the formula sheet of the exam, so you do not need to memorize these off by heart, they are provided to you. Okay, what we've been asked to find? We've been asked to find angle x. And what information have we been given? We've been given two sides and one opposite angle. Now looking at our rules on the right, we can use the sine rule when we have two sides and one opposite angle. A over sine A equals B over sine B. So let's plug in our values. 150 over sine x equals 140 over sine 66. Let's now cross multiply by sine x and sine 66. Now to get sine x on its own, let's divide by 140, and we get sine x equals 150 times sine 66 over 140. Now to get x on its own, we take the inverse sine of both sides. So x is equal to the inverse sine of 150 times sine 66 over 140. And plugging these values into our calculator, we get x equals 78 degrees. Now, a note here, where no degree of accuracy is specified in the question, give your answer to the same degree of accuracy as the values in the question. So the question is not saying give your answer to 1 decimal place or 2 decimal places. So it's our choice in which degree of accuracy we want to give. We can give it in the same degree as the values in the question, which is 0 decimal points. It's rounded to the nearest whole number. Or we can choose to give it to a different degree of accuracy, but if we give it to a different degree of accuracy, we should state that in our answer. For example, 78.2 degrees to 1 decimal place. Our next question is a bearings question. 2018 paper 2, question 13 for 4 marks. A ferry and a trawler receive a request for help from a stranded yacht. On the diagram, the points F, T and Y show the position of the ferry, the trawler and the yacht respectively. Fy is 7.2 kilometers, Ty is 5.6 kilometers, Ft is 10.3 kilometers, and F is on a bearing of 240 degrees from T. Calculate the bearing of the yacht from the trawler. Okay, so we've been given a diagram with all the dimensions and the sizes marked on it, which is a great start for us to help visualize and solve the problem. Our first step as always is to label the sides. Side T is opposite point T, side F is opposite point F, and side Y is opposite point Y. Okay, we should also label the angle we are trying to find. Now we've been asked to calculate the bearing of the yacht from the trawler. Bearings are measured clockwise from the north line. So the angle we're looking for is shown in green. Let's call this angle X. Now looking at angle X, with the information that we have, how can we work out this bearing, the bearing of the yacht from the trawler, angle X? Now looking at this, we can see that if we can find out the angle within the triangle, FTY, or angle T, we can add this to 240 degrees to find angle X. Okay, so now this becomes a triangle question. So, do we have a right angle triangle? No, it's not a right angle triangle. So when it's not a right angle triangle, we can use the sine rule, or we can use the cosine rule to help find the size of a missing angle. Okay, these formula, as mentioned before, are provided to us in the formula sheet of the exam. So we are asked to find the angle. So how do we find an angle? Well, in this case, we have three sides. We have side T, we have side F, and we have side Y. When we have three sides, we can use the cosine rule to find an angle. So the cosine rule for our question would be cos t equals f squared plus y squared minus t squared over 2fy. Let's plug in our values. 5.6 squared plus 10.3 squared minus 7.2 squared all over 2 times 5.6 times 10.3. Cos t in our calculator would be 0.7421 and onwards to a number of decimal places. Taking the inverse cos of both sides to get t on its own gives us t equal to 42.09 degrees to 2 decimal places. As we said, x will be equal to 240 degrees plus this angle. So the bearing of the yacht from the trawler is 240 plus 42.09, which gives us 282 degrees 0.09. Our final question is also a triangle problem solving question. In 2019, paper 2, question 19 is for a big 5 marks. Katie and Mona are looking up at a hot air balloon. In the diagram below, KM and B represent the positions of Katie, Mona and the balloon respectively. The angle of elevation of the balloon from Katie is 52 degrees. The angle of elevation of the balloon from Mona is 34 degrees. And Katie and Mona are 350 meters apart on level ground. Calculate the height of the hot air balloon above the ground. Now we've been given a diagram showing triangle KBM, and it's marked on with the two angles and the side that we have. So that's a great start. Now first what we want to do is label the sides as always. So side K is opposite angle K, side M is opposite point M, and side B is opposite point B. Next we want to draw on what we're looking for. So in this case we're looking for the height of the hot air balloon above the ground. This will be the perpendicular height of triangle KBM. Perpendicular meaning it's at right angles to the base KM. So we have a right angle triangle within our larger triangle. Now when working with right angle triangles, we can use the trig functions, SOHCAHTOA, to work out the length of sides when we have an angle. So if we're using the angle 52 degrees, angle K, we are looking for H, which is opposite angle K, and we also may have side M, which is the hypotenuse of the right angle triangle. So opposite and hypotenuse, we can use the sine function. So sine x is equal to opposite over hypotenuse, or in our case, sine 52 is equal to h over m. Rearranging this for h, we get h equals m sine 52 degrees. So if we can find side m of this right angle triangle, which is also side m of the larger non-right angle triangle, we can work out h. So how can we find side m? Now let's take a look at the larger non-right angle triangle KBM. What do we have for this larger non-right angle triangle? Well, we have two angles, 52 degrees and 34 degrees, and one side. So we have one side and two angles. When we have one side and two angles, we can use the sine rule. Okay, but to use the sine rule, we need to have the angle opposite the side we have. So we have side B and we need angle B, which is opposite side B. So this is marked on the diagram. You can see angle B. Now how can we calculate angle B? Well, the sum of the angles of a triangle is equal to 180 degrees. So we can use this knowledge to calculate angle B. So angle B, to work that out, we know that 52 degrees plus 34 degrees plus angle B will equal 180 degrees. That means angle B is equal to 180 degrees minus 86, the sum of the other two angles. So angle B is equal to 94 degrees. Now that we have angle B, we can use our sine rule. So in this case, it's m over sine 34 is equal to 350 over sine 94, angle B, which we have just found. Let's rearrange this for m. So m is equal to 350 times sine 34 over sine 94, which gives us m is equal to 196.2 meters to 1 decimal place. Now that we have m, we can jump up to the top again and put it into our equation to find h. So h is equal to 196.2 times sine 52. So h is equal to 154.6 meters. So for this question, we needed to work with a right angle triangle and a non-right angle triangle to arrive at our answer. Next steps, section revision and section test. So by now you should have covered all the learned material for this section. You should have stepped through each individual topic's learned material, watching the videos or reading the text to learn about the skills within that topic. You should have stepped through the practice for each topic and continued the practice until you mastered the skills for each individual topic. And you've just completed the exam prep topic for this section. So what's next for you? Okay, you should do the section revision, which is in effect more practice. In this section revision, you will be presented with questions that will cover all skills within this section, and the questions will be at an exam level. As with other practices, the questions will be supported with hints and full work solutions to assist in your learning. Please practice and revise until the system confirms you have mastered all section skills. Once you've mastered, you then move on to the section test. So please take the section test, and once you've taken the test, your test will be immediately marked and graded, and you will then be able to review the results of the test. You can step through all the questions that were presented in the test, and full work solutions will be presented. You should study solutions for any questions that you happen to get wrong, and close out any knowledge gaps by revisiting the relevant topics learned in practice areas as required. Once you feel you're ready, you should come back and take the section test again. You should repeat this cycle as many times as required until you consistently achieve a score of 90% or greater in the section test. Remember, the time and effort you put in now will develop your skills and also build the confidence you need to take into your exam. One final note before we close: print off the crib sheet for this section, which summarizes all the key skills you learned in this section. You can write your own notes on the back of this crib sheet, and in that way you will have a handy one-page reference for the section as a whole.